Hello. In this video, we're going to continue studying logarithm rules, and to do so, I want us to look at something kind of weird. We're going to have log 2 plus log 2 plus log 2 plus log 2 plus log 2. So on a calculator, let's go ahead and do that. Log 2 plus log 2 plus log 2 plus log 2, all those log 2's. And you should get, in this case, it's going to be a decimal, 1.505 and so on. Okay, now calculate 5 log 2, in other words 5 times log 2. You should get the same answer. Kind of strange. And then the best one of all, log 32. 1.505. What's going on? What do we notice here? Well, I think the fact that these first two give us the same should be kind of obvious. I mean, it's sort of like you got an x and an x and an x and an x and an x, right? If you have x plus x plus x plus x plus x, you have 5 x's. And so the fact that the first one and the second one give us the same thing, I think kind of makes sense, because now we, instead of a bunch of log 2's, we just have 5 groups of log 2. But what about that 32? Well, if you think about it, 2 to the power of 5, isn't that 32? Yeah, which kind of makes sense, because, well, 2 to the 5, that would be like 2 times 2 times 2 times 2 times 2. So if instead of adding, we times it all, we kind of have the same thing. It's a bit of an interesting sort of thought process. Let's look at how these two are the same. But let's rewrite the 32 as 2 to the 5, because we know that 32 could be written as 2 to the 5. Well, if log of 2 to the 5 is the same as 5 log of 2, well, notice the 2 is still in the same spot, but the 5 has sort of done this. It's gone from up top and jumped down to become a coefficient. It's almost like the 5 used to be a power, and now we've got a coefficient. So what do we notice? Well, we have this sort of idea. Log of 2 to the 5 could be written as 5 log of 2. If we write out the letters, log of a to the r is r log a. Anytime you have an exponent inside of a logarithm, you can take that exponent out and make it a coefficient in front of the logarithm. This is our third and final log rule, and we're going to now use it with the other log rules to practice some expansion. All right, let's go ahead and expand fully. And by that I mean, let's take the logarithm that's just a single log, and let's write it out with all the log rules we can. The multiplication we know is going to become addition, and the division is going to become subtraction. So if we were to expand it, think of it as like kind of exploding it, bursting it as much as possible apart. The 4 and the 5 and the 11 will each become their own logarithm, plus because of the multiplication and subtraction because of the division. All right, try that on the next one. We have log 5 to the 6 times 4 to the 11. Can you expand that out as much as possible? All right, you should have something like this. First, we could write it as 5 to the 6 plus log of 4 to the 11. But that wouldn't be the end, because those exponents, we could rewrite them as coefficients. So the 6 could come down, and the 11 could come down. And that would be it fully expanded. All right, this one looks like a lot of fun. We got some letters, some exponents. There's even a 3 in front. Go ahead and pause the video and give this one a try. All right, so we'll have 3 log x to the minus 5 plus 3 log root y minus 3 log z to the 4. because there's a 3 in front, you can either think as like this whole thing has a 3 in front, and so we're going to need to multiply in the 3 to all 3 terms. But that gets like super messy, and so what I just did is multiplied the 3 already, because there's a 3 for the first log, a 3 with the second log, and a 3 with the third log. Okay, now we're going to take these exponents and bring them down. And when they come down, they have to multiply because there's already a coefficient sitting there. So 3 times minus 5 is minus 15 log x. The square root we know is a 1/2. So we're going to bring this as 3 over 2 log y. And the 4 we're going to bring down with the 3 to make it 12 log z. And that would be the logarithm fully expanded. Okay, the opposite of expansion is compression, or in this case, we could say condensation. So let's go ahead and condense fully these logarithms. We have lots of logs. We want to condense them down into a single log if possible. Go ahead and pause the video and give the first couple a try. All right, so we might see this addition and be tempted to start multiplying things. But because we have these coefficients in front, we can't do the multiplication step first. We have to do the coefficients. We have to deal with these. So this will become log 6 to the 15 plus log 9 to the 4. The coefficient's going to have to hop up. Now, once they're out of the way, we can use that addition becomes multiplication rule. And now we're good to go. So that's condensing the 2 logs into a single log. Let's try it again on the next one. First, we got to hop up those exponents. For fun, I'll write that as a root. Oh, a third, that's like a cube root. That's extra fun. And then here we've got z to the 4. Now remember, the ones that are plus become multiplication. So we'd write log root x multiplied by z to the 4, because that addition becomes multiplication. But we would divide by the one that's subtracted, so divide by the cube root of y. The subtraction becomes division. All right, one more to try here. Again, we're going to go ahead and hop up those exponents. So log x to the... Ooh, that's... Yeah, I should probably show you that. When the 2 hops up, there's already a 3 there. So it's like log x cubed squared. So you get log x to the 6, right? Because the rule is power to a power we multiply. So 3 times 2 is 6. Using our exponent rules while using our log rules. This one will be y to the 6 times 4, which is 24. This will be log z to the 8. Oh, and we've got a 1 on the end. My goodness. Well, we can't combine the 1 with the logs because it's not a log. But you know what? It's sort of like a sneaky log. Because if we're doing log base 10, I know that log base 10 of 10 is the same thing as 1. So I'm going to rewrite this as log 10 because I need it to be a log so I can use my log rules on it. It's almost like it was a log initially and some silly person decided to actually evaluate it into a number and we're like, no. We need it as a log, so put it back into a log so we can use our log rules. Okay, one single log, so the plus goes on the top and the subtraction goes on the bottom and we're good to go. Now one last one, I'll let you pause the video and give this a try. It's a bit of a puzzle. There's a way to evaluate this and you don't need a calculator. All right, so assuming you gave it a try, we're going to go ahead and condense this into 6 to the 12. Here we'll write this as log 3 to the 3 times 8. But now we're at a bit of an impasse because the division can't turn into more division. We have not quite the setup we'd want for a log rule. The 8 is a 2 cubed, So we could rewrite this as log 6 to the 12 divided by log 3 to the 3 times 2 to the 3. And here's where it gets a little interesting. If you have 3 to the 3 times 2 to the 3, it's kind of like you had 3 times 2 to the 3, right? Using exponent rules, but in reverse. And 3 times 2 is 6 to the 3. So we could write this as log to the 6 to the 12 over log of 6 to the 3. Well, let's just bring those exponents back down. We have 12 log 6 over 3 log 6. Now we can't use exponent rules here or log rules, but we can just cancel. I don't need to know what log 6 is to know that if I have the same thing on the top and the bottom and it's multiplied, I can cancel them out. So this will give you 12 over 3, which is just 4 as a whole number. And if you want, I'd encourage you, type this into your calculator. Type in 12 log 6 divided by 3 times log of 3 plus log of 8. And if you hit equals, it should give you a very satisfying whole number of 4. All right, let's go ahead and take some notes real quick. So we were doing some more log rules. The new one we learned today is that log of a to the r is equal to r log a. This is pretty useful if you want to expand or condense something. We also learned, just as a trick, if you see a number like, let's say 2, that would be the same as log base 10 of 100, right? You can take numbers and rewrite them in terms of logarithms if that ends up being useful. And so we also did condensing. Condense is where you have a lot of logs and you condense it down to just a single log. And of course, the opposite of this would be expanding, which is where you go up. You'd have a single log and you'd expand it out into multiple logs. So for an example, let's try to expand log base 2 of root x times 3 times y divided by z. All right, assuming you gave that a try, you should get log 2, we'll take that 1/2. So log 1/2 x plus log base 2 of 3, log base 2 of y minus log base 2 of z. So it also works if the base is base 2. Just so you know, a question like this usually shows up on the exam, and it's usually worth a couple marks. So I find it, once you've done the log rules a couple times, these are some pretty nice marks to get on the exam. So practice them up and look forward to doing a nice quick question like this on the exam. For some extra practice, you can do Unit 9, Worksheet number 3, and then write down any things to remember. All right, hopefully you enjoyed this video, and as always, thanks for watching.